Hello, everyone, and welcome to another SaferSim webinar. Today, we have a project that was sponsored by both SaferSim and the AAA Foundation for Traffic Safety. And I'm going to hand the floor to Bill Horry to say a few words about the project.
Thanks, Don. And this is, as Don mentioned, this is one of the projects that's kind of under a large collaborative effort between the AAA Foundation for Traffic Safety and the SaferSim consortium, UTC. And this has been a very successful multi-year agreement and partnership. And I believe this is the eighth, that's eight projects that has kind of fallen underneath that umbrella, and probably a dozen or so different reports and outcomes and things like that. And so on a variety of topics. And so we've been really delighted with the success of this program, and kudos to Don Marshall and all of the leaders and students and faculty within the university's part of the UTC. And so again, just a great outcome. And Apoorva is going to talk about the latest and greatest from this effort. And so without further ado, I'll turn it over to her to kind of walk you through the results of this effort.
Thank you, Bill. Hi, everyone. Thank you for joining us. I'm Apoorva Hungund, a PhD candidate at UMass Amherst. Welcome to our presentation. Today, I'll discuss the first part of a two-phase project we're conducting with the AAA Foundation for Traffic Safety and the SaferSim organization. The research today is about identifying outcome measures to evaluate drivers' knowledge of vehicle automation. So today, I'll first provide a bit of background about the research, our goals and objectives. Then I'll talk about how we went about identifying relevant measures and wrap up with some key takeaways and discussion. But first, let me introduce our research team. Like I mentioned before, this project is being done as part of a collaborative partnership between SaferSim and AAA FTS. Other than me, we also have Meng, Professor Shannon, and Professor Anuj from the Human Performance Lab at UMass. And we have Bill Horry, who is here in this meeting, Jessica and Austin previously from the AAA FTS team. So as we all know, vehicle automation aims to improve the safety and comfort of drivers. But the vehicle automation available today, does this by either providing support, warnings, alerts, or by temporarily taking control of part of the driving task. However, to reap the benefits of using automation, drivers need to use automation responsibly and in situations they should be used and within their limitations. However, drivers are known to not always be familiar with the limitations of such systems and can very easily misuse them, like overusing them or using them in situations they should not be used, or expecting more of them, like expecting a system to be fully controlling the driving task instead of just, for example, controlling speed or lateral position. But it is very important for us to understand how much drivers know about vehicle automation in their cars and how they interact with them. Previous research has focused on both of these aspects, and it is very clear that providing even a little bit of relevant information will improve drivers' knowledge and use of such systems. Some of the measures previously used include knowledge, trust, workload, interactions with such systems, or perceptions. But it is not always clear how these measures are affected by different levels of knowledge, or if a particular education method improves one measure while not being ideal for another, or if drivers' knowledge how drivers' knowledge can impact trust or perceptions, for example. So understanding how these measures change and interact with each other can help us in calibrating effective learning methods, effective training methods, and it can also help us in understanding how we go about delivering such content effectively. Therefore, the goal of this research was to identify and evaluate outcome measures that are used to assess knowledge of vehicle automation. We did this by conducting a review of literature, established standards, reports, conference proceedings, We also conducted interviews with subject matter experts on the different measures, their interactions with each other, as well as the data collection process. Finally, we gathered a list of measures related to multiple aspects of driver's knowledge and their interaction with vehicle automation. So let me just explain each of these steps in a little bit more detail. First, with respect to the review, we compiled a list of keywords related to vehicle automation and education of drivers. So we referred to keywords like driver, driving, training, education, licensing, etc. We then conducted a literature review search of the TRID database and Google Scholar. Search reports search records included journal articles, like I mentioned, conference proceedings, technical reports. Relevant records were identified through title culling, and then we looked through abstract of each of the titles we thought were relevant and then resumed the culling. Finally, we were left with 49 relevant records. We downloaded each of these research papers, and then we extracted study details, specific features, characteristics of each research, and most importantly, the measures that were used in these studies. And then we also evaluated standards, specifically SAE J2944, which details recommended practices and operational definitions of driving performance measures, and SAE J2396, which details eye glance related metrics and statistics. Finally, we also evaluated outcome measures from 6 recent studies conducted by Human Performance Lab at UMass and SaferSim UPC. After this, we conducted a workshop to gather input from subject matter experts regarding knowledge, education, and training. This included 2 experts from academia, one from industry, and one from, one from a government organization. We started off with a general discussion, followed by a roundtable discussion on measures to evaluate the effectiveness of consumer education. Through this process, we received input on measures related to system interaction and operation, user experience, time of data collection, training materials, driver characteristics, and of course, knowledge. We then compiled a list of all the measures we had gathered through literature and standards. This included survey measures that were used to directly measure knowledge, or system interaction variables such as how many times did a driver press a button to turn ACC on or off, and other such related measures. The comprehensive list in the end included over 120 variables. We then added input and notes from the subject matter experts to add to measures related to system interaction and user experiences. Finally, the research team engaged in a sort of interactive and iterative process whereby we discussed each measure, and then we discussed like the broad categories these measures would fill in. And we essentially distilled outcomes into 9 broad categories, which you can see on your screen. The categories include measures related to control, transition, system interactions, safety events, system understanding, attitudes, workload, usability, driver attention. And all of these measures were compiled in the form of a huge matrix. I would have loved to show you guys the complete matrix, but as you can imagine, it won't fit. I do have a quick snapshot of it. For people who are just dialing in, we have a broad category of each measure, and then we have the details. Then we have context, and then we have the level of complexity of implementation of that specific measure. And then we also have the pros and cons of each measure. I can come back to this in the end if you want. So we have some key takeaways from our research. The measures vary greatly in terms of implementation and their relation to system knowledge. Some of them can be directly addressed through training and education intervention. They can be improved or they can be calibrated correctly, but this is not as simple as it sounds, and it's not applicable to every measure. And while measuring knowledge is the best way to understand driver's knowledge of vehicle automation, it depends upon conditions and it may not always be feasible. Measures related to control, transition, and system interaction are directly related to appropriate and safe use of vehicle automation, but the conditions to do this can be difficult to recreate for every participant coming in. Furthermore, environmental or situational factors can impact measures that can be measured directly. I'm saying measures so many times in this presentation, as measures related to attitudes, perceptions, and workload, while can be recorded directly, they're just as easily, they're just as easily affected by other factors. And measures related to driver attention, they've been extensively used, and there are multiple methods of implementation. It's very practical to use it in the real world. Since there's so much extensive literature on how to do it. Lastly, while measuring and evaluating single measures is less complex and easier to do, combinations of measures can provide a higher fidelity and provide more robust insights into driver's knowledge. With that, I'd like to talk a little bit more about the future work we have planned. So the next step was to evaluate the measures we discovered through the matrix. We decided on a multi-site simulator study. Both organizations, AAA Foundation for Traffic Safety and Human Performance Lab at UMass, have a common platform, this RTI simulator. We decided to use the same drives, the same scenarios, study procedures, and of course, collecting the same measures at both sites. We've completed data collection, and we are now in the process of finalizing the data evaluation plan. Both studies will be compiled and published under one report, so please keep an eye out for that. And with that, we come to the end of this presentation. If you have any questions, I'll be happy to answer.
Thank you. I'm going to open the floor. If you have a question, please feel free to unmute yourself. If that's not an option you prefer, then please feel free to type your question in the chat and I'll read it for you.
I do tend to talk a little fast, so if anybody wants me to go back to a specific point, I'm happy to do that. And I'm going to bring up the small snapshot I have of our matrix in case anybody wants to take another look at it.
Thank you. Can't see anyone typing. I haven't seen, of course, I haven't seen results from the second phase of the study. Do you have any predictions or thoughts about, it's hard to say, but do you have any just inklings about what you expect to see?
Bill might have better insights on this than I do.
Thanks, Don. Yeah, we're Apoorva just said, yeah, we're just in the process of kind of polishing this up right now, and so it's kind of fresh on mine. But we've actually done kind of looking at a whole array of different outcome measures and kind of using a random forest approach to identify the key factors involved. And what we're seeing so far is that it really makes a difference, the sort of measurement window or the scenarios in which you're entertaining. So whether you're looking at just normal driving conditions versus takeover scenarios or non-takeover scenarios, system interactions and so forth. The unit of analysis is sort of one important feature. When it comes to like the features of interest, we're finding that measures of eye glance behavior are actually pretty robust predictors of driver knowledge. And, I think that does make a certain amount of sense in as much as how a driver allocates their attention is often a reflection of, how they perceive the system and what they're supposed to be doing, in as much as in these scenarios, drivers are supposed to be monitoring the system. They're also supposed to be monitoring the traffic environment and so forth. And so I think we're seeing a little bit of commonality there. But yeah, there's just a ton of things that are going into the modeling that hopefully will be of interest and importance. But what we're trying to do with the final product is to really leverage this first effort that Apoorva has talked about here, and kind of bringing in a whole novel data collection effort as well to kind of generate some key takeaways. And so we're close, and we're hoping to have that done soon.
Thank you. Thank you. I was, as you were speaking, I was looking at what Apoorva has up on the screen, and that fits in the, if I'm reading the prose, what you were just saying, this column seems to point to all of that. With the skills, rules, knowledge. So the level of experience and facility with the system that people have, they're not, I was just thinking about that. Sorry. Rambling out loud going,
Well,
yes, yeah. I wouldn't be able to predict it from the table. It was like, yeah, that makes sense, doesn't it?
Yeah, and adding to what Apoorva was saying too, not to steal any thunder, but I mean, this is just a snapshot, as she mentioned. I mean, this is like three pages of tables, and even this one is condensed, and we're going to provide a full version as an Excel spreadsheet that people can link to and utilize as well. So at least that's the overall aim.
Yeah, we started off with like putting everything on like a Word document, and then literally taking every single measure and then discussing what sort of broad outcome it like fit, if it fell into like multiple categories. And then we had like I think there were like so many rows in the first Excel sheet that we put together, and there were like light versions of it, and then there was like a full version of it, and then this is sort of like the final product.
Yeah. Well, it's a huge space that you're trying to sort of distill and drill down into. That's not, we're not trying to dismiss the effort of the first phase of the project. That's a huge effort to try to get a focus on things, with one, without missing anything important, and two, without going, sort of off in the left field because of something that, what do I want to say? Maybe preconceived bias, because we're all researchers and we all have our ideas about measures and what measures are good for what. And so I'm really excited that iGlances are coming up as, maybe, and I can see that you're pointing to that here. I was trying to give people a chance to unmute themselves or type something. I haven't seen anybody do that. But is there anything else that you want to tell us about that big process?
Maybe Apoorva, you could reflect upon the lessons learned when it comes to multi-site collaboration with a common platform. I think we learned a lot, I'd say.
Yeah, we learned a lot. I think when we were initially setting up the process of data collection, like mimicking the data collection process at two sites, we had the AAA FTS team come into the human performance lab, and then we tried transferring files from our simulator and then theirs, to just make sure that cross-platform everything was still running okay. So the transfer of like the files back and forth, making sure that we had like the small things smoothed out, it was very educational. Like even having the same simulator system doesn't mean that the process will be as easy as just sending a file. Everything's complicated. But yeah, about the review process though, I think one of my personal takeaways from this is that maybe not all AI is bad, because when we first downloaded the results, we condensed it to like the 49 papers, but when we initially came up with the search results, there were like over, I think, 5,000 hits that we had to like go title by title and then go abstract by abstract to make sure these were relevant, because training immediately throws up like a lot of words towards machine learning. So you have to filter out very carefully. I think that is like one spot I would not like mind using AI perhaps, but it was some time ago, but I remember just reading a lot. I'm pretty sure my prescription has changed just because of it.
Thank you. Thank you. So with, if no one other attendees have any questions or comments, we can go ahead and end the presentation. I want to thank you for your presentation. I really enjoyed it. I have really enjoyed seeing the results of this collaboration between the Safer Sim Consortium and the AAA Foundation for Traffic Safety. It's been a wonderful experience. And so thank you, Bill, for helping make that happen. And thank you, Apoorva, for being part of one of the projects, or maybe even more than one of the projects. I know you tend to work on a lot of things behind the scenes. So with that, I'm going to thank everybody and end the meeting.